So yes, my name is Gregg Ganley. I'm the principal investigator on iMAS. And I also work with a colleague of mine named Gavin Black. He's my co-PI. We work at MITRE. We're both mobile researchers. MITRE's, just a quick bio on MITRE, we're a nonprofit company that generally works with government sponsors. And they have an internal research program that this is funded under. The idea is that we do this research, we're open sourcing it, making it available for our government sponsors to perhaps more easily integrate it in with their work programs. So just jumping into iMAS. So what is it? We're essentially iOS application defense in a nutshell. And more expanding on that, we're iOS. We're creating an open source application framework to reduce app vulnerabilities and information loss. That's kind of it in a nutshell. If you take a look at iOS and kind of the hacking and jailbreaking that's been out there, it's pretty well documented. There's attacks and weaknesses. You can go on the internet and download free briefings and presentations. There's also several books on Amazon. One can grab those books pretty quickly. If you're a developer, in a month or so, you can, after you get up to speed on Xcode and Objective-C and buy the developer's license and all that stuff, you can kind of jump into these books and figure and learn that there are actual vulnerabilities in iOS. The most recent jailbreak that's out there is by this group called Pangu. They had one for iOS 7.1 and 7.1.x. They also have just released iOS 8 and 8.1. It's only available in China, so they're still working. Apparently, they're porting Cydia to iOS 8, so it's moving right along. And for those not familiar with that, that's the whole notion of patching the OS, removing those security limitations, gaining root access, so that you're really disabling those key protections. Once the device is jailbroken, it's fairly straightforward to copy on a brute force passcode cracker application. That's what I'm showing on the top right there. And the idea is if you have a 4-digit passcode, you run this program on the device, and within 10 to 20 minutes, you can actually get the passcode itself. And once you have the passcode, you can disable a lot of the Apple key protections that are there. And one thing in particular, you really just can't copy the key bag off of the device, put it up into an Amazon cloud, and let the cloud chew on it to make it go faster. Apple actually puts part of the key, it's actually burned into the silicon, so they actually have like a 200 millisecond delay every time you access part of that key, so there's like built-in throttles to kind of slow things along. So the takeaway here is that users really should have a 6-digit alphanumeric, ideally a longer one. Like my company imposes a policy through good MDM service that actually makes it, forces us to put in a longer passcode. Apple actually quotes that, has stated that about 50% of devices out there don't have a passcode, and the ones that do are only using the 4-digit, so there is a vulnerability there. Just taking a quick scan of the news back in March, iOS is secure, but it turns out that if you scan the news, and a lot of the times, there are folks that are finding these latent vulnerabilities. And so here you can see that there's a lot of words in this slide, but the takeaway is that coders are still coding things incorrectly, and it affects iOS security. And then there are just pure iOS issues that are popping up, and Apple is patching them and releasing more and more fixes. Back in July 18th at the HopeX conference, John Jartsky, former gentleman used to work with me at MITRE, he exposed several Apple kind of backdoors. These are like, Apple quoted them as diagnostic utilities, but they allow you to copy large swaths of your passcode protected disk off device, and in particular, I believe it's pictures, texts, and the contact lists were exposed. He also found various daemons running, collecting network traffic. He put a blog up, and Apple claimed that they were necessary for diagnostics purposes. Interestingly, when I think that turned up the pressure, because when iOS 8 actually came out about a month ago, they announced a new policy that they actually disabled those diagnostic tools. And I don't know if you folks follow 60 Minutes at all, but just a few weeks ago they had the FBI director on there who actually commented on this, and who said that Apple's new policy on fully encrypting is somewhat of a threat to national security. So So you can see there's a little bit of a ratcheting up of what's going on here. But the takeaway here is that there was backdoors, and perhaps there could be more. But nonetheless, there are iOS vulnerabilities. And so my claim is that if you're looking at an iOS app, it's surrounded by particular areas of vulnerabilities: the 4-digit passcode, the memory, and when a debugger is attached to the device, you have some vulnerabilities there. When the device is jailbroken and root access is gained, there's lots of issues there. User access to a particular application itself. Apple doesn't provide, at least up till iOS 7, a way for an app developer to just put a passcode on top of an app. The other thing is the keychain in their flash data storage has different areas of vulnerability. So to that, we introduce iMAS. And the idea is that we're creating a secure application framework. There's a lot on this slide, but essentially we have these security controls or software libraries that we've open sourced beyond what Apple iOS provides. We're basically filling gaps for iOS. And the idea is we're reducing that iOS app attack surface. And like I said, we've open sourced it. It's up on GitHub today. Developers can download and make use of this. So where we sit in the iOS security architecture, if you take a look at kind of the OS stack of iOS. And most areas of the OS are gray because they're not open source. They're closed. Apple owns them. So as a researcher, you're really focused on you're really kind of in the app sandbox itself. If this was an Android stack, one could see there's all kinds of different areas where you could do security research because of the fact that it's open source. And at my company, we have lots of folks doing different Android security at different levels, and you can see that out in the commercial world as well. But with iOS, you kind of focus to that app sandbox. So it's my claim that on the y-axis, the more security controls you add to a device, to an application, or you expand your x-axis, or allows you to handle more sensitive information. As iOS has evolved, back when iOS version 6, 7, they had some security controls there. It allowed you to do enterprise level activities on the device. If you add in an MDM container or an MDM like an AirWatch or Good, you're getting more security. But there are still gaps in those offerings. And so with iMAS, through our open source offerings, we have even more security controls to the point where we think we can bring in sensitive information like HIPAA, for example, could be actually stored on the device and protected using iMAS in a way that would meet the HIPAA guidelines. And so we're into our third year of research now. Our fiscal year just started a month ago. And so the plan is to continue down that arc and continue to add more and more security controls. So just in a nutshell, kind of comparing the vulnerabilities and the security controls we have out there, there's quite a few. I'm not going to talk to all these, but the top left, where the 4-digit passcode, or there's no passcode on a device, we actually have a security control called passcode check, and that essentially, if you're a developer and you want to query the operating system to find out is the passcode set, and if it is it complex? There's no API for that. So we've come up with this technique using in passcode check that allows you as a developer to get that level of assurance, such that you can decide to kill the app, reduce the capabilities of the app, or alert the user, etc. But it gives you that programmatic control. Bottom left, encrypted CoreData and secure foundation. Those kind of the secure foundation has several kind of security primitives in there that other things, more deeper security can be built on top of. Encrypted CoreData in particular is basically encrypting the stock SQLite database files that come on the device, and I'll talk more about that in a minute. And then way over the right we have Encrypted Code Module and App Integrity, which is the point of this talk, and I'm getting to those slides shortly. So just to kind of put framework around some of the controls that can be used in an app, and those apps can be deployed to the App Store. Other controls would be specific to enterprise app stores. And the distinction there is that we're really targeting the enterprise and the particular needs of the enterprise and their capabilities. And so given that we're able to actually do more or provide more security because we're going outside the App Store restrictions. And so a couple of them, particularly the app integrity items that I'll show you today, are really enterprise app store only. So up on GitHub, we have these 13 controls. Here's kind of a list of them on GitHub. And if folks are familiar, are there developers in the audience? Oh, great, cool. So folks are familiar with stars and all the different forks. But essentially, we have about 500 stars. Essentially, those are developers that have shown interest in these particular projects. And then I think we're up to about 100 different forks. And 30 or 40 of those are people are actually contributing back. We're pulling forks, we're pulling pull requests back in, and Encrypted CoreData in particular, that community has somewhat of a life of its own now. So it's clear that there's a gap, and Encrypted CoreData is filling it. iMAS uses. If you think about a mobile device, when an enterprise kind of first gets them, they start off with very straightforward capabilities. Give the users email and calendar. Take these devices and be more connected. And then the next thing is that a user says, well, geez, I'd like to be able to kind of reach back into the enterprise. Could we use a couple of your IT-provided apps, like maybe your time card system or maybe the expense voucher system? And that's usually a web browser. So then they open up a thin client or a web browser back into the enterprise. And then finally, the user says, well, geez, I'd really like to be more effective on the road with my mobile device. I'd like deeper capabilities. Give me, and the IT says, oh, sure, we'll build you an actual native app, thick client that has kind of this offline capabilities, very rich user interface. And so those are kind of the 3 degrees. iMAS will work across all those different ones. We actually have a Sentry application, which is just a pre-canned app that bundles several of our controls in it. So one can download that, kind of build it, compile it, incorporate it into your MDM solution, and it'll augment your MDM solution and deploy it to those devices that just have email and calendaring. We also very easily can be integrated with WebKit. So essentially, if you have folks that, if your IT department is just deploying a URL where they're deploying the Safari browser, all good, but as you know, Safari browser has a cache, and cache leaves things behind. So the thought is that one could easily take our code and wrap WebKit and basically make a custom web browser for your enterprise that would secure it. And then native app, of course, is you can take all of our controls, parts of our controls, and work them into your device depending on your security level or security needs. So just drilling down into encrypted CoreData. If you look on the left, Apple provides a mechanism called CoreData, which is essentially an objective interface into on top of SQLite. So rather than have developers get familiar with SQL and relational databases and all that, they just have an abstraction on that. And ultimately, all the data is stored in SQLite. So as you read the news and you hear in hacker forums and whatnot, hackers essentially the first thing they do when they get a hold of a device, or if malware is on a device, is they're looking for these SQLite files, because they're plain text and they're chock full of interesting information. So the thought is that we've actually taken encrypted CoreData and we brought in SQL Cipher, which I used to have a graphic up there, but it's not there. But SQL Cipher is an open source project that we've bundled in with encrypted CoreData, and we've essentially replicated what CoreData does in encrypted CoreData with SQL Cipher. And so now, when in place, you actually, when the app is at rest, you would see ciphertext in there in place of real information. So that's the idea, and this is one of the most popular controls we have. And so the interesting part about iMAS is you don't just use pieces on its own. You actually can bundle it together with the other controls that we have. So app password, in this case, to actually do a full scenario of making use of the encrypted CoreData, the user would use app password to put in their passcode. Then that passcode would unlock an actual key that's for the database that's secured in our secure keychain, not using Apple's keychain. And then that key would be placed in memory using our secure memory control. And then from there, we would move the key onto the stack, which is less likely to be rummaged through and found. And that key would then unlock the encrypted CoreData. So the idea is you use these in concert for a holistic solution. This is the iMAS Sentry app I was talking about. Like I said, it just bundles a bunch of different controls together into an app that one can kind of deploy with their enterprise solutions. Just kind of spinning through a couple more of what we've worked on. Recently, we've done work on this whole notion of a multi-compiler. So we've kind of teamed up with, or we've taken the work from UC Irvine by Mike France and Per Larsen. And what they're doing is these guys have a technique that every time the app is compiled and linked, it actually rearranges the output so that the address of where the code is different. So if you have a guy that's fuzzing the app and he knows that offset, hex 200 is where I can jam my code in, every time that hex 200 is going to change. So it just makes it harder and harder. So what we've done is we've actually taken that and we've ported it to the Xcode environment, kind of built it into a standard iOS app, and we've actually got it working, and we've shown that you can actually see that there's no ops getting jammed in there, and that the output is different each time. So can you imagine if you could take this technology and kind of bundle it in with your enterprise app deployment kind of DevOps? Every time you do a build, essentially the output is changed. Pretty cool technology. And it's there. And so the folks at UC Irvine are more focused on kind of the PC Windows side of it, and so they're going to circle back to the kind of the iOS side of it shortly, and when they do, hopefully the variety of how they're changing the code will increase as well. So another one is iMAS System Monitor. This one's pretty straightforward. So you can actually go into the App Store today and download these particular apps: System Status, System Information, and they'll actually give you a list of what networks your phone's connected to and things like that. With System Monitor, we made it a programmatic control. So if you have an app and you want to keep track of what other apps are seeing or networks they're going to, this control can do that for you. You could create a little pseudo whitelist, blacklist to kind of figure out what's best and what's right for you. So this is a great control for that kind of level if you really want to get into it. iMAS file sharing. File shredding, I should say. So this is the notion that if you think about it there, when we store files onto the disk itself is looked at often, and you're leaving traces of that behind. So what we've done is we've actually come up with a way to actually write over the raw file contents, kind of climbing through each inode with a random pattern, and we're using it as part of our dynamic library technology that we're going to talk about in a moment as part of Encrypted Code Modules. So anyways, it's kind of interesting. It's there, and if folks are concerned that when you do put a file into the sandbox, here's a technique to quickly kind of shred it when you're done with it. So let's talk about app binary arrest research, particularly encrypted code modules and app integrity. This is kind of leading into where I'm taking the talk. So I looked into this a little bit, and folks, there was a research done back in over 10 years ago called Shiva, where these folks looked at advances in ELF binary encryption. And it was pretty interesting stuff, where they actually tweak and change how portions of objects are instantiated, and they're doing individual security checks on each kind of function call. That was presented at Black Hat 2013, and then 2003, and then 6 months later, some folks came out with a reverse engineering of Shiva to kind of show how you could get around it. But interestingly, there was still value there. We also looked at University Leuven in Belgium. These folks had another interesting technique back in 2006. So there is some precedence for folks actually taking a look at different ways that you can try to kind of modify the ELF structure on the fly in for secure purposes. For us, our focus is on mobile iOS dynamic libraries and how we can somewhat manipulate those. So the whole point of static attacks, or I should say, what I often see when I go to these security conferences is that folks put up all kinds of research about static app attacks, different ways that you can grab the application and kind of get into it, reverse engineer it, and essentially find out these sensitive algorithms and change the binary. So the whole point is to sidestep the security measures. One particular technique for iOS is if one has IDA Pro, which is a fairly expensive tool, $5,000 or so. With IDA Pro, you can actually take an iOS app, decompile it, and take it back to C code. And at that point, the algorithms could be understood, the binary could be patched, and again, you're sidestepping security at that point. There's other tools out there where John Jartsky, again, is actually a blog that talks about different ways to patch the OS, patch the binary itself. Now that you understood it, you decompile it, now you want to patch the binary. There's techniques out there that do that. AppLidium is another kind of write-up on that. And the whole point is that once you understand the code, you can then nullify and truly patch over the security. The consequences of static attacks are pretty grave. IBM put out this really cool picture where it talks about all the different consequences to application owners, and in particular, brand and trust damage, revenue loss and privacy. There's user experience compromise, intellectual property theft, unauthorized access and fraud. So there's a whole list of bad things that are associated with these static attacks and cracking them and actually making fraudulent new ones. So that's kind of the background on why we really focused on this. So introducing encrypted code modules. This is a new security control that we have in iMAS. And the idea is that we want to isolate sensitive algorithms into dynamic libraries and compile those at compile time. You encrypt that plain text into encrypted text, and you bundle it with your app. Again, this would be deployed to the enterprise store because this technique is strictly off limits for the app store itself, for good reasons. Then you want to run the app, decrypt the dynamic library, and load it at runtime. And this is going to help protect you against static attacks. So here it is kind of in a picture form. I'm showing where you use Xcode, you have some sensitive algorithm, in this case application integrity check, the idea of checksumming your own app. And you would compile that into a plain text dynamic library comes out, and that's typically what you would then, plain text, it's bundle, it's binary, but it's plain text, it's not encrypted. You would then, typically you just bundle that with your app. The problem is that library, if it's on the device, can be brought down with the device, brought down with the code to an attacker who can then put it into IDA Pro and reverse engineer it. So you really want to encrypt that dynamic library. And so we've come up with this dynamic library bundler tool that actually does that. So that after it goes through the tool, it's then encrypted, and then you can bundle that in with your iOS app. It's signed and part of it. So just to be clear, so at build time for this concept is you're creating your dynamic library, and then you actually create what I'm calling an application key, and that's what that key is there. You then pass it into this dynamic lib builder, and the output is this basically encrypted dynamic library file. Once built and bundled in with the app, on first install of the app, the user would actually type in that application key along with a passcode to unlock that app. And so we're going to take that application key, the one that was created at build time, and we're going to store that with the app, but encrypted using the app's passcode. So basically there's two keys going on here. We're wrapping one key with the other. And so the idea is that they only have to do that in first install. In all subsequent use, you just put in your application key, and that will unlock the other key, which then opens up the dynamic libraries for use. So on the device, when the device is at rest, you're seeing here that you have your iOS app. It has the encrypted code module dynamic library with a lock on it. So if the attacker took that and actually kind of brought it back onto their laptop and brought it into IDA Pro, they would just see large swaths of ciphertext that they really couldn't get to. When the app is in use, we're actually, once we unlock it, you're unlocking that critical functionality that can then be used dynamically to kind of do the special thing you need to do, in this case, app integrity. Excuse me. So applying ECM, app integrity. So the idea is that, like I was saying before, the iOS static attacks, they're somewhat common. Again, code can be injected, the binary can be patched to compromise the app. You really want app integrity to help kind of thwart those techniques. And implementing app integrity is pretty tough because it's essentially a checksum, and checksums are vulnerable many different ways. And so, technically these are called cryptographic hash functions, and they can be leveraged. They mitigate against app tampering, but like I said, they're a checksum. The security difficulties is that there's known good values of the hash, and securing that because if that's tampered with, then the whole game's busted. Or securing the algorithm is really tough, particularly reading the file, calculating the checksum, comparing checksum values. So it takes some thought and techniques to figure this out. So here's kind of it in a nutshell, and that's really hard to read. So let's just start with step one. So it's basically 3 Xcode projects that you use to make this. And the idea is that you start off with, you have an Xcode project that has your sensitive algorithm, and in this case, the app integrity check. And so you build that, and the output is this dynamic library. Now you have to be aware that up on our GitHub site where we have this posted, there's a lot of techniques that talk about how do you get Xcode to actually allow dynamic libraries on the iOS platform. And so you have to kind of look, you got to basically tweak Xcode a little bit to make it work. So anyways, once that's done, your output is this dynamic library that is in clear text. So the next step is to go over to your Xcode project of the actual app itself. This is the one that is, this is your real app that has the app integrity built into it. And once you have that, you pass in essentially the dynamic library and the app into this dynamic bundler builder. And this actually does the checksum and creates that known good value. And then in the end encrypts that dynamic library with that known good value in it, such that and then it bundles it into the app itself. So when done, you have this demo app that is actually ready to go and usable. So at rest, your known good values are encrypted inside the app. The algorithm is encrypted. File read, calculating the checksum, comparing checksum values, all those actions are all encrypted. So if the attacker got this, they would have difficulty getting into that dynamic library, considerable difficulty. So this essentially forces the attacker away from the static forensics and into that whole dynamic forensics. And that's really what you want to do, because that's a whole other level of skill, a whole other level of expertise. Script kiddies aren't going to run out by a $5,000 IDA Pro tool. And even then, there's a lot more to it. So at app startup, like I was talking about, the user puts in their app passcode, that unlocks the app and unlocks the dynamic library. We then decrypt the dynamic library. We read the file into memory using DL open. So at this point, we now have a file that's plain text on the disk for a brief micro window, and that's where file shredding comes in. We then run the file shredding program to quickly shred that file once we've loaded the symbols in memory. And so that's kind of in a nutshell so now you've actually taken that dynamic library and you've securely have it now running in memory. So at this point, you can validate the integrity of your app by reading the app file size, calculating its SHA hash, comparing to the known good value that was inside that dynamic library, and then decide, hey, is it good? Is it bad? Did it match? Did it not match? And you can programmatically kind of decide, what are the next steps? If it didn't match, do I exit? Do I alert the user? Do I degrade functionality? If it did match, you can carry on. I'll do a quick demo. It's a video demo. So let's see. It's a little hard to see, so we'll give it a try. Hopefully, folks will appreciate it. So the idea is that I have an iPad on the right here, and oops, move that out of the way. And so I'm going to essentially run the application that is kind of the demo app that works. So I'll tell you what to pay attention to in a moment here. So the user puts in their passcode, and once the passcode is put in, they'll press in this demo, we press the Perform App Integrity button. And when that does, you see, hey, success. But what actually happened here, and yeah, it's very tiny. But essentially it went through all those steps that I just described, and it actually compared the file size and the hash, and both compared. And so the app does have integrity. The checksum is validated. I can show you this demo afterwards if folks want to see the actual output. But anyways, if you keep running it here, the next step is that we'll actually run an app, another app that actually fails, and it can fail in two ways. If the key for the dynamic library decryption doesn't work, that's this particular one. Again, demo app, so we put in our passcode. Here we actually enter the key. It wasn't. It's not. We actually type in the key that's unlocking the dynamic library. Again, this is the demo. Typically, this key would be like how I described it before. It would actually be saved as part of the app, and user wouldn't have to type this in. So again, we put in a bad key, and it runs. It fails, and what it's saying here is that hey, I decrypted it, but then DL open attempts to read this garbled ciphertext as correct binary and tries to load it into the symbol table, and that fails dramatically. So that's what you see here. And then finally, the last part of this demo is that we run it this time with kill those old apps, and when we run it again, and we put in the correct key to decrypt the dynamic library, but this time the checksums don't add up. And if that happens, so put in the correct key, which happens to be key, and when it runs, down in this lower portion here, it's basically saying that, hey, the app file size and the hash value didn't match. And again, this is where you programmatically can decide what to do. In this demo, we decided to just say fail. Yeah, so that's kind of the quick demo in a way. So it is, kind of code that's actually working and running. Let's see if this takes me where we left off. Yeah. So the takeaway here is that encrypted code modules on iOS has a lot of advantages. You can really try to use them to protect against that static attack. Force the attacker to go to the dynamic attack, which is again a more advanced skill set. The encrypted app code itself is now protected against targeted tampering, and apps with encrypted code modules on them, you can again protect sensitive algorithms, protect intellectual property. You can use apps that checksum themselves. And then you can kind of protect the security controls using themselves. Like we could try to, we've been trying to think of, wouldn't it be great if we could actually take 90% of the app and put it into the dynamic library, and then the app itself is only the small little 10%, like just a launcher. So we're kind of experimenting with that. But with this, you can think of many different ways to go with it. So this was open source just about a month ago up on GitHub. It's called ECM and Encrypted Code Modules. It's up there. And like I said, for iMAS, we're part of OWASP, but we're listed under the mobile tools section. iMAS is right up there. We've recently partnered with iGoat, which is actually an interesting way to kind of learn about security. You download the iGoat app and teaches developers what's the wrong way that this app is being secured, and then it teaches them to shows them the right way. We actually added some iMAS security to iGoat. They had OpenSSL cryptos on it, and we brought them up to the Apple cryptos. And so we're working with Ken Van Wyck and Jonathan Carter on that. That's all I had. If folks had questions, I'm a little early, faster than I thought. Sure.
Have you measured the potential performance impact of using the ECM?
Not yet. It's for our test, the dynamic libraries are pretty small. Anytime we've done those kind of decryption, we haven't even begun to think about performance. The chips there are pretty fast. It would have to be a fairly massive dynamic library and whatnot. And remember, we're decrypting it once, then loading the symbol table, so it's kind of, it's only a one-time thing every time you use the app. Hi, yeah.
The lib key that you dynamically you encrypt the library, dynamic library,
yes.
And then the encrypted library will be in the App Store. Then the user, the first time I guess the downloader, the user will need to enter the key. Is that what you said?
Yeah, the idea is this is an enterprise, right? So you trust the user because they're an employee of yours, and to make the app work right, they got to put in the key itself. And ideally they're not posting that key and telling others about the key because,
so it's the same key for all the users.
It could be. This particular technique, it could be, but maybe we rig it into that multi-compiler, and then maybe we rig it into have unique keys per user. Maybe when the user goes to download it, we have a button that says, "Oh, you want this app? Hold on. We'll compile it. We'll add in a new key.
Yeah.
We'll multi-compile it. So we're going to change the output of the binary to change the variety of the binary, and then poof, you give them a custom app that has their own key." Yeah.
Okay. And then I assume it's a long key, the user enters, and then you use the app password to encrypt this key.
Right. Yep. Yep. Yep.
And you don't trust the keychain.
Don't trust the iOS keychain, unfortunately, because you're trusting the user to ensure that they have put in a long passcode. Half of them don't have a passcode, the other half only have a 4-digit.
What about the iCloud?
Say it again?
What about the iCloud synchronization?
We haven't looked into that just yet, but that's kind of on our roadmap. Yeah, yeah. Sure.
Is there any way to know which applications are using some of these tools to be more secure?
That's always a good question, because the question I get is,
Average user, what the heck do they know?
yeah, right. Well, the question I get is, well, Greg, why the heck are we open sourcing this? Can't the bad guy just go to the open source, see how we do it, and make it? So the idea is that when you do use it, or when a company decides to use it, they usually keep that kind of on the down low. That way, you're not really talking about, hey, I use this algorithm. But the other thing is that usually, companies can also use different algorithms. We're one open source repo that's out there. There's a few others they can kind of fold in. So it's this combination of all the different things you use. From a total on the user side of it, I don't know. I haven't really thought about much of like the direct user itself. I mean, obviously we try to make it simple for them to unlock an app with a quick passcode, and then all of the security is kind of happening for them. Haven't really thought about that much.
Just for deciding what apps to download.
Yeah, right. This always gets back to try not to, we always want to encourage developers to not roll their own security. And so here, we've done the security rolling, we rolled it ourselves, but we've also hired third-party companies to actually vet what we're doing, to make sure that, that we're doing best security practices when we build these security controls. So that's another plus about what we're doing, is to kind of offload your organization from having to pay developers to get smart and all that. They can just kind of download our stuff and integrate it. Yeah, it would be great if it could be kind of stamped, secured with iMAS kind of stuff. But
Right, that's what I was thinking. Yeah, stamped with iMAS. So, you know, but
Yeah, I have a question.
Sure.
You mentioned a couple of tools that you can download. What array of tools are available to the users as well that they can download?
Oh, yeah. Kind of like App Store apps that are like secure wallets and things like that. Is that what you mean?
Yeah, just what kind of applications. Yeah, I think you mentioned a couple of secure browser or something.
Yeah.
System monitor, things like that.
Oh, right. Okay. So from a end user perspective, the users wouldn't necessarily download what we have. This is more geared towards enterprise IT that would be downloading what we have and incorporating as part of their MDM solution.
Yeah, I just thought maybe you had a few user tools as well.
Unfortunately, we really don't. We're kind of focused on that. You think about what MITRE's trying to do. We're trying to enable the government to get to these more secure platforms faster. And so that's where our focus is. It's less about the consumer side of it. Yeah.
Do you have similar tools for Android?
No, we do not have, we'd love to do research in that space. We're versed on Android, but we haven't been funded to do said items, but we'd like to. Yeah, I think there'd be, Jack, how, on the Android side, I know Jack just spoke before me, and do they have similar tools like this on the Android side, or just the native apps themselves?
Little onesies and twosies, but not that as robust as what you guys put together.
Yeah.
And close,
So there's definitely a gap there. Yeah.
no other questions. I just should say too, this presentation will be available on, I guess, the LastCon site. He's given me a copy, so we'll be posting it. Any other questions? No other questions? Let's give it up for Gregg.
Thank you.